Yeah, so we're going to talk to you about Spark and Kafka. And we're going to tell you the story about Spark and Kafka by way of another project that Skyla and I have invested a lot of our time in over the past several years, and that's Cloudant. If you were here last year, you heard us talk to you about Cloudant's heritage in open technologies. It's based on Apache CouchDB, and we talked about how that particular project and its commitment to open technologies, its commitment to HTTP interfaces and JSON payloads, made it a really good foundation to build a cloud service, something that could scale up to hundreds of servers and hundreds of terabytes of data and down to mobile devices. It's provided us with a great foundation in Bluemix. It's the most active service in Bluemix, and it's something that our clients are building applications on, our teams within IBM are building applications on. It's a very flexible, powerful, scalable system.
But we know that there are some limitations, and we've had some challenges, and we haven't had a good solution for being able to do, ad hoc, analytical type queries and what-if analysis, sort of unpredicted types of queries. And that's where it's really exciting to think about Spark and what Apache Spark can bring to us today. It's really an application framework that allows you to do highly iterative application or analytic workflows. And it's really exciting in that it's really taking the industry by wildfire. And it's becoming incredibly popular. It's the fastest growing project in the ASF. And it's not just because it's, enables people to work collaboratively, although that is an interesting piece and something we'll talk a bit about some more, but also because it's fast. It's lightning fast. In fact, it just set a new record for the TeraByte Sort benchmark. Now, that had previously been held using the Hadoop technology, where it was able to sort 100 terabytes of data in 72 minutes using like 2,100 nodes. Recently, they just reset that benchmark using Spark with order of magnitudes improvement. So they did it in 23 minutes with only 206 nodes. So it was like 3x as fast and an order of magnitude less hardware behind it. And so, it's really exciting to be able to see this kind of advancement in technology coming along. And it's also because of the user experience. So it really allows a unified and collaborative environment across data engineers, application developers, and data scientists in a way that hasn't been possible before. There's a unified API for both streaming as well as batch type of analytics, and it also comes with a wide variety of tools and a powerful set of tools in the broader ecosystem. So whether you're familiar with using SQL and want to work with the structured data that you may have there in that type of a construct, that's available with Spark SQL. You can work with real-time data coming in through Spark Streaming and integrate machine learning algorithms into your analytic application easily with the libraries, as well as integrate graph types of analysis. And it's got a great way to access a wide variety of data sources and bring them into a single place to leverage all of these different analyses together easily. And IBM is investing heavily in Spark. Last year we started the Spark Technology Center out of San Francisco, and we have over 300 contributors working actively in the open source community to make Spark better and stronger. But it's not only the Spark Technology Center and contributing, it's really about additional efforts where we're actually leading new projects around Spark. One example is Apache Tori, which is really about enabling applications to be able to interact or be able to work with Spark interactively. A new one that we're happy to announce today is Apache Project's Stockator, and that is a new driver that will enable much more efficient access to data in object storage. And we're talking 10 times faster. So there's a lot of innovation going not only into the core of Spark, but also into projects and the broader ecosystem around Spark as well. And we're also on a path to help educate over 1 million data scientists in terms of using and leveraging Spark. And not only are we working on the open source, and on the open source side, we're also leveraging Spark internally. So we're learning how to run Spark well ourselves by delivering Spark as a service on Bluemix. We're also embedding it inside many of our internal software offerings and helping our clients to be able to do the same as well. And when you think about this, there are, it's so much exciting things going on with Spark, and it really is speeding up the pace at which we're dealing with data and how quickly data is coming. And it makes you think about how you interact and bring data into the system in a different way.
That's absolutely right. Yeah, that one, not the other one. So, as Skyla was saying, Spark's emphasis on interactivity, its support for streaming analytics, and its overall, move away from the world of batch reporting that runs overnight to a world where you're interactively exploring the data and you're building analytic applications directly against this in-memory system, means that we start thinking less about data as a repository, a static place, a database, and more about flows of information that are coming into your environment, that are powering your decision-making processes within your organization. And when we think about those data flows, there's a construct around them that really has to change. It's a paradigm shift in the way we think about the information. We need new technologies that help us manage those data flows, and the one that has stood out among the rest these days is Apache Kafka. So Kafka has a bunch of really good things going for it. It's a messaging system, traditionally, right? But in the Kafka world, they shifted a lot of the logic away from the server and put it on the clients and kept the server very fast, very simple, very scalable, and very robust, right? So when I say fast, I mean millions of messages a second on 3 small machines. We're not talking about hundreds of machines powering this cluster. A few cheap machines can give you a message bus that can ingest about whatever you can throw at it. It scales horizontally, it can partition the topics, and it can ensure that you're able to reliably process the information. At most once or at least once processing by default, and with some smarter clients, you can even get better semantics around how you process the information in these topics. It's got extensive support throughout the industry. It's something that was originated at LinkedIn, where they sort of said, they took a step back and they said, okay, we've got databases all over the place. We've got databases for analytics, for log trail analysis. We've got, core user information databases. And we've got this mesh of integrations between them. And every time we bring a new one online, we got to add a new integration, right? If you think about the scalability of that problem, it's an n-squared problem. And so they took a step back and they said, okay, what if we could actually have a consistent bus, like we do for messaging between services, but that was focused on the data? And that's what they came up with Kafka. And it's seen tremendous adoption throughout the industry. At IBM, we've embraced Kafka with our messaging organization, the same organization that brought you to MQ in the enterprise messaging space, with our message hub in Bluemix. It's Kafka as a service and more. In addition to the Kafka interfaces, it's got traditional AMQP interfaces so that you can do application messaging. And it's got a RESTful endpoint. When you look at Message Hub's sort of centrality throughout Bluemix, not just in terms of application messaging, but in terms of data, you have a really interesting picture that emerges. In the first case, you've got a hub for asynchronously connecting services inside Bluemix, information that needs to be shared between 2 of these Bluemix services. In the second case, if you're going down this cloud-native application development that Dave and Rachel talked to you about, and you're getting into the world of microservices, a reliable message hub helps you allow those services to scale independently, to operate independently, and to communicate as they need to, right? So it can, give you the flexibility and the freedom to move very, very quickly within each individual service. And then finally, the reason Skyla and I are here is because Kafka allows us to represent our data and our databases as these topics of information that flow into the analytic environments, like Spark. And it's not that you have to pick one of these use cases and stick with it, right? If you're using the Message Hub for application messaging, for service-to-service communication, you've got that one standard place where now, if some of that data becomes an interesting thing for you to analyze in Spark, or in a streaming analytics service, or in Elasticsearch, you have a standard way, a standard topic that can publish the information into those services. So at IBM, we talk about being open for data. And as you've all seen in this technology summit, across the organization, we embrace open source technologies. We figure out how to operationalize them. We figure out how to quickly deliver value for our clients based on these technologies. With CouchDB, we have the foundation of our flagship cloud database service, Cloudant. And with Spark, we have our analytic operating system, a system that knows how to talk to all kinds of data in all kinds of repositories and present a common, fast, in-memory optimized interface to extracting insights from that data. And then finally, with the Message Hub and Apache Kafka, we can tie our services together and keep the data flowing where it needs to go. Thank you.
Thank you, guys. That was wonderful.